Welcome to your first NVDA app module session 6, APIs. This one is the last session in your first NVDA app module session. So we'll be mostly talk about APIs and how to use it and some of the final thoughts before we close this session. For the past few weeks, we talked about what app modules are, scripts, we talked about objects, events, and in the last session, we talked about overlay classes and what they are. You learn how scripts work, you learn how to assign keyboard keys at least to app module. You can assign other keys if you want, and touchscreen commands. That's more towards the intermediate level. You learn how to work with objects, object hierarchy, object properties, and whatnot. There are other ways of working with objects. You learn about events, how to deal with events, how to actually queue something so that it can be done after something occurs. There are other more advanced ways of working with events. There are more internal events that NVIDIA raises besides NVIDIA Object Init event. And you also saw how overlay classes work, such as scripts and events inside overlay classes. You can do other things with overlay classes as well. So those are some of the things that you can do with app modules. There are other advanced things that you can do with app modules. Some of them you will not see it in this course. Some of them might be offered. Some of them perhaps you will learn it as part of an intermediate or advanced course. I might be teaching it, someone else might be teaching it, but at least objects and events and overlay classes and scripts are the things that you do need to know as you write at least some app modules. Some will require more, and some will indeed work best if you can work with APIs, application programming interfaces provided by the app in question. As far as beginning modules are concerned, this is the last one. And after that will be intermediate level and advanced and whatnot. So intermediate level will consist of things like text infos, how to work with text infos, various other things related to objects, more accessible stuff, more UIS stuff, and Java Access Bridge perhaps, and working with Windows. Advanced topics will involve more internal NVIDIA objects, working with add-on handling, more advanced GUIs and whatnot. So those should be some things that you might find perhaps in intermediate or advanced level. And advanced level might also talk about tree interceptors and then other advanced topics. So to start with, let me talk about what APIs, application programming interfaces, are. An API, or application programming interface, is a set of contracts or documentation or code that allows programmers to work with specific tools, application systems, and whatnot. For example, on Windows, you have Windows API, sometimes called Win32 API, where you can use functions you heard like find window X, create process, terminate process, open process, and all those. And other apps like Winamp have their own application programming interfaces using messages back and forth. Office applications, at least for Microsoft Office, allows you to use what's called Component Object Model, or COM, to talk to it. Like, for example, getting the message count of a folder, getting the name of a contact in Outlook, among other things. There are other ways of working with other apps, like using Visual Basic for applications with VBA for Office applications. And for LibreOffice, OpenOffice, they have their own ways of doing things, and among others. It's a sort of a special kind of APIs, like accessibility APIs, like MSA, Microsoft Active Accessibility, or Accessible. There's UI automation or UIA, just Java Access Bridge or JAB, among other things. So today is mostly going to talk about accessibility APIs and some other APIs used by certain applications, chiefly Winamp and Office, to show you what kind of things you can do with APIs, at least read your code. And for some of you, for many of you don't need APIs. You guys can use events, objects, and whatnot to deal with applications. Some cases you do need to create overlay classes to deal with specialized controls and provide specialized logic and whatnot. Some of you will definitely might want to dive into APIs provided by the app. So let me start by giving some description of some accessibility APIs. So let's start with accessibility APIs. Accessibility APIs are the primary interfaces that screen readers and other assistive technologies and sometimes apps use when they need to seek out information for users. For example, what kind of control it is, the name of a control, label, technically that's what it's called, the value that's associated with the control, like a progress bar, output, and whatnot. So in Windows, there are two dominant ones in use. There's MSAA, Microsoft Active Accessibility. It came out in 1990s, and although the uptake wasn't, not many people took advantage of that when it came out, more and more screen reader vendors are taking advantage of this. And it's sort of used as a foundation to support other APIs. And accessible, that's what's sometimes called, gives vendors a chance to test screen reader APIs and learn about how the other APIs work, at least to give them some kind of a foundation to support other APIs. Accessible is limited in what it can do. It cannot work well with modernized controls, for example. And to react to changes in modern controls and to give more modern feel, Microsoft introduced UI automation, UIA, in mid-2000s. And it's become standard on all Windows releases since Windows 7. Windows Vista's version of UIA isn't quite reliable, and so is XP's. So when it comes to UIA, which is more practical when it comes to working with modern controls, it will require, at least for NVDA world, it requires that Windows 7 or later be installed in order for UIA to function correctly. And newer version of UIA is available for Windows 8 and specifically on Windows 10 at this point. So these use what's called Common Component Object Model, or COM, or COM, to talk between each other, at least what UIA does. Basically what COM is, you have two programs that might be written in different languages. Like C++ versus Visual Basic, for example. What it can do via COM is each application can tell others what kind of information they can access. Like for Excel, it can access the sheet, the cell itself, what's contained in the cell, the address, and whatnot. For Outlook, it will be the name of a contact and whatnot. These are provided in a standardized way, so it can work across different languages. And Python does have a library, external, that allows people to work with COMs, called COM types and whatnot. Win32 COM, that's what the module is, and COM types for certain cases, where Python can talk to COM processes or processes that exposes component object model or COM based interfaces to allow other apps to access certain information from them. And for accessible, at least with MSAA, COM is behind the scenes, Comm is used. The client-server model isn't defined precisely for MSAA, although it is there. For at least for UIA, UI automation, the app that you wish to run an app module for, or app that you are working with, is termed a UIA server. A server is a computer or a service a tool that provides a service like file sharing, media, and whatnot. In case of UIA, a server is an app that provides necessary services and that exposes some of the information that what's called clients can consume or use to allow people with disabilities to work better with applications. And clients in UIA world refers to assistive technologies and others like screen readers and that accept information sent in by servers and interpret it in certain ways so that users can work more efficiently with apps. So UIA is termed a client-server model. Two tools, one tool provides services, other tool uses it to its advantage. The alternative that's used in the programming world is peer-to-peer or P2P, where two programs cooperate with each other and work together for a common cause. That's what P2P is, work together. So no client or server is involved in that model. For the most part, NVDA provides abstraction so that it can work with across different comm processes, different APIs. So that, for example, if you have an app that's filled with accessible objects like MSAA, or like depth info ends with accessible stuff, or if you have another app that has UIA, like UIA element and whatnot, despite differences, NVDA has a way to locate object.name, object.value, object.role, and so on. And in some cases, NVDA does allow you to use specific interfaces provided by each accessible API. For example, iAccessible role, iAccessible system label, and whatnot, and for UIA element and whatnot. For UIA, each control on the graphical user interface are termed elements. And so each widget on the screen is termed an element, and these have different attributes like what the cached class name is, what the automation ID is, what the framework is written in, and whatnot. Accessible, there's really not a lot of distinction. There's accessible role, accessible child ID, which is used mostly in containers or lists and whatnot to allow you to see the position of the element of an object. So there are a lot of things that you can do with things here and there. So that's the accessibility API. As opposed to that, the APIs that other apps use are application dependent. For example, in Office applications like Microsoft Office, they have their own specific APIs like Comm. For Winamp and other derived applications, including Station Player Studio, they have their own APIs. And for Winamp family, what happens is there's a function in Windows API that allows applications to talk to each other by sending messages back and forth. And Winamp family uses that extensively, so that in order to obtain certain information from Winamp and other apps like SPL, what happens is NVDA will send a message, and as part of a message, NVDA will tell the app what it should return. The app returns something, and NVDA can do whatever it wishes. For example, for Winamp, there's a specific message that one can send to obtain if a repeat is enabled and whatnot. So that is what APIs can do, and you can in some cases use Windows API in your apps to do things like find a specific window or locate the handle for a specific object. A handle is an opaque reference to something like a file, some piece of data, network sockets, network connections, and whatnot. So you can use that for several things. And for some Windows API functions, you do need to know what the handle for window or object is, or it's going to get handled for process and whatnot, in order for the Windows API to say you can do things here and there. So those are some of the things that you can use APIs for. Let me give you a quick demonstration of some of the APIs that people have come to appreciate for the past few years in their app modules. Let me start by giving you an example of a Windows API function. You can use it in app module. Sometimes you don't have to. Let me attempt to find
NVDA Python console breaker edit blank.
Let me use a Windows API function. Sometimes use this for in case. Let me use a Windows API. Let me try to get version. To get the version of the Windows that you're using. Sometimes you'll need to use specific references to this. So let me use import when user.
Breaker.
Let me
6 symbol level all.
Let me win user dot user32 dot get version. My parent.
Trace map left paren most recent call left right paren colon file quote less console breaker quote comma line 1 comma in less module breaker file quote c type snap slash line edit line dot pick quote comma line 378 comma in line get after line file quote c type snap slash line edit line dot pick quote comma line 383 comma in line get after line attribute error colon function tick get version tick not found.
Oh yeah. So
on Android
might not be the one. What if I have this win user dot user32 dot find window A? Many Windows API functions have ANSI and wide character or Unicode versions. NVDA defaults to using Unicode. Sometimes you do have to use ANSI. So what I want to do is attempt to find a specific window.
Left paren.
Let me say, for the sake of this demonstration, let me type in what SPL Studio does. SPL.
Oh, PS.
Now press enter. What I typed is
win user.user32. Find window left paren quote SPL Studio quote comma none right paren.
This is using SPL Studio app. Now press enter. None is when you hear the word null in Windows API documentation, substitute that with none, capital N.
0 breaker.
It means no handle at all because Studio isn't running. Otherwise, I would have gotten a handle for Studio. So if you just do like you use the find window, it'll just do find window W. Otherwise, it'll define window A. If you have to be specific on what version to call Windows API, you can do other things like let me import
breaker.
Win kernel. The APIs that are demonstrated were user32.dll. This is kernel32.dll. Win kernel kernel 32.
Less win DLL tick kernel 32 tick comma handle 77 minute win kernel dot kernel 32 blank.
That let me see what I can. Let me see. Get date format. My parent. Most of the Windows API functions require you to have several parameters, but for this one,
recent call left right paren colon file quote less console breaker quote comma line 1 comma in less module breaker file quote c type snap slash line edit line dot pick quote comma line 378 comma in line get after line file quote c type snap slash line edit line dot pick quote comma line 383 comma in line get after line attribute error colon function tick get date format tick not found breaker.
I don't know why it's maybe I'm doing something wrong here. So that is there are other various functions out there for Windows API. Some might be because I'm remembering it wrong. So
Team Top 5 Classic.
So that is what is up. Let me attempt to find
NVDA Python console
foreground.window class name.
UTIC number 32,770 tick. Breaker T.
Okay, let me attempt to do this. Win user.user32.get find window A, let parent number 32770. None.
3,343,506. Greater.
In that case, it did return a handle. I don't know. It returns the first window. The handle for the first one. I don't know why it's doing that. So that if it gives you something other than 0, that means it did define something. So that's a handle, and you can assign it to some kind of a variable and use it throughout the app module if you wish. Note that handle values do change across runs. So you should not rely on handle values being the same across sessions. That's Windows API. Now the Winamp family API, courtesy of Hoye Tarek for giving me permission to use his extended Winamp as an example.
Sound type preview searched with app module number NV app module app winamp.py.
The format of the Winamp
selected send message find ClientServer is joined channel select tab return win user dot send message left paren self dot hwnd winamp comma wm line wa line ipc comma 0 comma ipc line get line shuffle right paren.
Now this is a shuffle command, so S command for Winamp, and this is how Winamp gets its messages.
Tab return win user dot.
And for this one, shuffle, it is
number app find dialog selected the IPC line get line shuffle equals 250.
So this is a send message method in user 32. It requires a handle. It requires the kind of message you wish to send. For example, 1024, which is WM user, and the parameter or the white param.
Message from ClientServer is not. I can hear you find dot.
So white param, which is a parameter to the message that you want to send, like turn it on or turn it off or not, and the L param, which is the actual message that you want to send. For example, the complete implementation is WinUser.send message let parent handle to Winamp window, and then WM user from user 32. And there's whatever that you want to do, and 250. So the complete message implementation is this: send message from user 32. So it'll be win user 32 dot send message in the parent. In some cases, you have to put send message A, send message W. Handle to Winamp WM user W param L param. So this is the complete thing.
Win user dot user 32 dot send message left paren handle to Winamp comma WM line user comma W param comma L param right paren.
This is for Winamp family where it uses messages to send back and forth information. In this case, if you want to enable shuffle, for example, you find that shuffle information will be 0. So the complete message is
win user dot user 32 dot send message left paren handle to Winamp comma WM line user comma 0 comma 250 right paren.
So this is the message that would send to find out if shuffle is enabled in Winamp, among other things. And you can do things in scripts like if you have something enabled, then announce or not. So that'll be, so that's what's happening here. The other example is
client submenu team talk app module.
The other example is Outlook,
items add-ons,
where
items and sort items new list Outlook.com.
I'll be using this to demonstrate how calendar view works.
Find it. D. S. Select the tab CLS list not class calendar view left tab blank tab line last start date equal blank tab def line generate time range text tab start text equals win kernel dot get time format left paren win kernel dot locale line user line default comma win kernel dot timeline no cons comma start time comma none right paren tab end text equals tab start date equals start time dot date left tab end date equal tab if not calendar view dot.
So
tab start text equals %% test tab blank def is duplicate access tab return font blank tab def event line name change left tab pass Blank. Tab def event line state change. Tab path. Tab def report focus left. Tab if self dot app module dot outlook version breaker equals 13 and self dot app module dot native colon.
Omni refers to object model. So we are looking at component object model for Outlook here. So basically what will happen is if you land on a calendar item, like a time range, time slots and whatnot, this is how NVDA can find out, can locate some of the information it needs and report focus to you. So basically what the Outlook will do is it will look, what the Outlook app module will do is it will use component object model to locate the needed information, like start date, the name of the appointment, and whatnot.
Tab equals self.app module dot native dot active explorer left paren right paren.
So this is an active explorer.
Tab s equals e dot selection.
So it will look at the selection that's, so at least like a time, currently select the time slot and whatnot. This is again using COM, component object model.
Tab if s not count greater 0 colon. 4 tab p equals s not item left paren 1 right paren. 4 tab tricolon. 5 tab start equals b dot start. 5 tab end equals b dot end. 4 tab accept com error colon. 5 tab return super left paren calendar view comma self right paren dot report focus left paren right paren.
And this was required because sometimes Outlook's journal, which is part of Outlook, says is listed as a calendar view apparently, but it technically isn't. So it's somehow through COM error or component object model error in some cases.
4 tab t equals self dot line generate time range text left paren start comma end right paren. 4 tab number translators colon. A message reported when on
and so on. So the actual method to get the native
number app find dot select the tab def line get line native left paren self right paren colon.
This is the Outlook. This is
tab def line get line
part of Outlook app module in this case. So again, this is from NVDA's core source code.
Tab tricolon native unselected. Tab native equals Comm Helper dot get active object left paren quote Outlook dot application quote comma dynamic equals true right paren.
Comm Helper. This allows NVDA to talk to component object model processes and whatnot.
Tab accept left paren com error comma Windows error comma runtime error right paren colon. Tab if self dot line has try dot look app switch colon. 4 tab log dot error left paren quote failed to get native object model quote comma x line info equals true right paren.
We do, for a component object model, we do need object model and there because it opens up a lot of possibilities to looking inside the object. In this case, Outlook, the application is the topmost object that NVDA is interested in. Sometimes we don't get it.
Tab native equals none. Tab if not native and not self dot line has try dot look app switch colon. Tab self dot line register com with focus double left paren right paren.
And this is quite an interesting function itself.
Tab return none. Tab self dot native equals native Tab return set len. Tab def line get line Outlook version left paren set. Tab def line. Tab native equals self dot native
Again, Outlook version is again another part of is a component of the object model that Outlook exposes.
Tab if native colon. Tab Outlook version equals int left paren native dot version dot split left paren tick dot tick right paren left bracket 0 right bracket right paren.
So that is Outlook that version.
Tab else colon. Tab Outlook version equals 0. Tab def is bad UI window left.
And so forth. So bad UI. This is again part of app modules, which means sometimes Microsoft unfortunately ships with broken UIS server implementations, and Microsoft Office is filled with that, unfortunately, say. So what happens is sometimes it is best to not use UIA for certain controls. It's better to use accessible in some cases. And this is more towards advanced cores, where you can actually define what bad UI objects are, and NVDA will fall back to accessible for some of them.
Tab def event line NVDA object line edit left paren self com tab role equals object dot tab window class name
and so forth. So we saw this last time.
App module.
At least we saw how it works last time.
Team top 5.
So that is
libraries.
So these are some of the things that you can do with component object model. You do need Comm Helper. Comm Helper has some of the goodies in there, but basically it's powered by COM types and Win32COM and whatnot. So that's a component object model version, and again, in itself, it's sort of an API, where NVDA can use Comm to its advantage when it comes to making some apps accessible. And some apps will definitely require using application-specific API. Some you can use just objects and events and whatnot. But as for determining what to use APIs and whatnot, it is up to the app vendors to tell you what needs to be done. But for the most part, you can just use object, event, scripts, and overlay classes and whatnot. But for some cases, you do need to use APIs to make life easier. And one of the advantages of using APIs is that you don't have to fiddle around with objects and events a lot. You can just use the API provided by the app and do things here and there. And it's more efficient than, say, using API that get foreground object and moving through the object tree and getting what you want. So that is the object model. That's the API WinNet family and whatnot. There are other things in
Channel message from Polyaslever is not. If I understood exactly, the Comm Helper is a specific Python module for navigating this question.
It's a Comm Helper. Let me look at if the source is there.
This PC window.
This, if I remember right, is part of not Python but part of NVDA.
NVDA format 9. Item sources items. Config format what Comm Helper.py 45 of 188. Content
and Comm Helper, this is not a native Python module. This is an NVDA specific module. You will need to use Comm Helper if you are indeed dealing with an app that uses component object model. And for me, this should be used as sort of a last resort. For the most part, apps should be made accessible from the app vendors, as noted in the first session. But sometimes you do need to use Comm
apart of non-visual desktop access left NVDA right copyright left C right 2013 NV access limit this file is covered by the GNU see the file plan quote utilities to help with issues related to com quote import subprocess import C types import com types not client not dynamic from com types import unknown from com types not automation import dispatch import OLAC import config
OLAC, object linking and embedding accessibility. That's what powers Microsoft Active Accessibility in the first place.
Blank. Import config. MK line line unavailable equals -2 billion. CO line line blank. Def line L result from get.
Along other things, they provide some workarounds with some quirks with COM types and whatnot. So that is what Comm Helper is part of NVDA. You should use it if and only if you do need to use component object model. Some processes do ship with Comm, others don't. For the most part, accessibility of an app should be looked into by app vendors themselves, not screen readers, as noted earlier. It's just my thinking. But sometimes you do have to use Comm, and that's what Comm Helpers are for, to give workarounds and whatnot. But I think they should be used as a last resort, and if it's better to use Comm Helpers or Comm for certain tasks. So that is what it is. At this point, are there any questions at this point? So, is there any other topic, like one or two topics that I should talk to you about? Things that we haven't actually discussed in this course. In the course, we talked about what app modules are, bare minimum app module, what scripts are, how to work with objects, object properties. We talked about events, we talked about overlay classes, and for today we talked about APIs and whatnot. Are there any one or two more topics that should be talked about before we end this course? Okay, so I would say for now we'll say goodbye for your first NVDA app module course. To give you the summary of this course. The goal of this course was to teach you how to write your first NVDA app module for those who are really beginners to this art and science of creating app modules. You learned how you can talk to app developers about making the apps accessible and how to write a bare minimum app module. You learned how scripts work, and you saw a behind the scenes tour of input help mode and whatnot. You learned to write your first script. and you learn how to refine your first script in some cases. And then you learn what objects are, object hierarchy, object properties, and how to work with objects and fiddle around with it. You learn what events are. You learn callbacks. You learn event handling. You learn queuing events and whatnot. And then you learn overlay classes, how to write scripts in overlay classes, how to handle events in overlay classes, NVDA object in an event, and whatnot. And then you learn some introduction to the APIs, like UIA. It is brief overview of UIA accessible in some key, and then you heard different APIs used by different applications. So the overall goal of this course it is to give you essential information to get started with writing basic app modules. And there are other things to it when it comes to writing a truly magnificent app modules. Some of the things that we haven't covered, which may show up in intermediate or advanced courses if people want to create one, are text infos where you can use it to navigate text within widgets. Touchscreen key assignment, more work with events, working with UIA events, accessible events, some goodies with these APIs, Java Access Bridge, working with Windows, more APIs, some of the do's and don'ts with Windows API app modules, and whatnot. So those might show up in intermediate or advanced courses. And overall, the goal is to teach you to be successful when it comes to writing app modules and making the experience of users a great one when it comes to using specific apps. But in order to make apps accessible for users, it is important that app developers take note of accessibility and work with users and others so that their apps can become accessible and usable out of the box for those using keyboards and others, and especially for those with disabilities. And for app developers, I hope this gave you some idea of how screen reader developers work when it comes to writing app modules and making your apps accessible, so that you can do something about your apps and make them more accessible, not only for NVDA users, but for users of other assistive technologies. For app module writers, I hope this course taught you how to write your first NVDA app module, and looking forward to seeing your app module knowledge grow. And one day, perhaps you can teach other beginners about how to write the best and the most magnificent app module ever. For users, I hope this gave you an insight to how certain things work, how app modules are created, and whatnot. And with that, folks, we'll call it a day. Thank you for joining your first NVDA app module course. Contact information. I'm Joseph Lee, one of the contributors to NVIDIA Screen Reader Project. You can contact me via email at joseph.lee, Joseph, Lee, Lee, 22590 at gmail.com. My Twitter handle is Joslee, Joslee. If you have any questions about NVDA, please feel free to contact various main NVDA users. There are experts now on the NVDA community who are more than happy to answer you. As for app modules themselves, you can ask I and other app module writers. And I cannot answer all the questions. That's a disclaimer. That's I think I can tell you. I myself, I'm still learning as to how app modules work and writing better app modules. There are other app module writers who are more specialized in whatever the app they do. Like some people work with Comm processes, some people work with Winamp family, some people specialize in events and whatnot. We do have many people in the NVIDIA community who are more than happy to give you suggestions on making apps accessible. And for app developers, you're more than welcome to contact NV Access so that NV Access folks can tell you give you suggestions. And in some cases, NV users can also give you suggestions on how to make your apps accessible, usable, in some cases fun to use by many screen reader users around the world. Thank you very much. It was an enjoyable course, and I look forward to meeting you again at some point in the future with a different course or different event and whatnot. And with that, this is Joseph Lee signing off.